Good day, this is Professor Elliott, and today we are going to look at voltage divider biasing of NPN BJT transistor. So here we have the basic circuit over here on the left, and the voltage divider gets its name for the voltage divider relationship between resistors R1 and R2. You'll notice that we have a single power source, VCC, and we have a collector resistor and an emitter resistor. All right. So my little model here is what we're really trying to solve, and that's how we're going to get ultimately the base current. And so first of all, we need to solve for RTH and VTH, which are the Thevenin resistance and Thevenin voltages respectively. And okay, so here's their sort of defined down here, and hopefully you learned about these last term. So let's carry on, assuming you did. All right, so here we have the Thevenin equivalent circuit of an NPN voltage divider. So again, my original circuit, and in this case we are considering the transistor to be the load. So we're simply going to pull that out. Okay, it's what you do in Thevenin's theorem. You remove the load, and to calculate VTH you sort of look back in to the circuit with the load removed and determine the voltage that you see, which in this case is going to be resistor voltage R2, which is what we expect to see over here. That's exactly the same voltage. Okay, so we can say then that the voltage V2 is the same as the voltage applied to the base of the transistor, and is the same as the Thevenin voltage. Okay, so that takes care of that, and then you're going to record that value like that. The other thing to do is to calculate the Thevenin resistance, RTH, and by doing that you remove the power source, VCC, you replace it with a short circuit, resistors RC and RE are open, so they're not going anywhere because they're sort of dead-ended, and obviously then R1 and R2 are going to be in parallel, and what you end up with this is a little partial Thevenin equivalent circuit. Now we need to get the rest of it here, but that's the basics. Okay, so make sure you're comfortable with that before going on. And so anyway, so I'm going to go back. So the missing bits that we need to calculate are this Rn base and VBE. So let's take a look at that. Okay, so we have Rn and Rn base. So let's imagine moving emitter resistor Re over to the base side, and when we do that we need to multiply Re times the current gain, the beta. So let's just say the current gain is 100, and we multiply it by Re, so that then gives us the value of beta DC Re, or simply Rn base, of 60 k ohms. So the 600 ohm emitter resistor looks like 60 k ohms from the perspective of the base. Okay. This parameter Rn is what is the DC resistance, how many ohms do I see looking into the entire voltage divider. Okay, so Rn is not the same as Rn base. It's given by this little formula here. So let's go back and let's do a little clean up here. Okay, so right now we've learned how to solve for that. We've learned how to solve for that. We've learned how to solve for this. And then the sum of RTH and Rn base is simply this. That's that value. That's the value Rn. Okay. So this is going to be my base current IB. VBE is simply the base to emitter diode drop, and it's going to be 0.7 volts. Okay, here's the important formulas for calculating the base current. Alright, so I think we can go on to a bit of an example. Okay, so here's all the given values. Here's our basic voltage divider circuit. So I've sort of broken this up into different segments, I guess. So the first segment, we're going to calculate VTH and RTH. Doesn't really matter which one you calculate first. And then we're going to calculate Rn base and then Rn. So you must do those two in that order. And then once we have that, we're going to calculate the base current. Okay, once again, there's the formula. And then we're going to get the collector current. And the collector current is beta times larger than the base current. And then once we have that, we can calculate the collector and emitter resistor voltages, the collector emitter voltage, and the collector voltage. So anyway, so we'll pick up this in class. Refer to the course manual. There's more stuff in there. And do take a look at this, please. It is important. And if you go over it thoroughly before class, you will get a lot more out of our limited time together. So anyway, thanks for stopping by, spending some time with me, and wish you all a great day. Thanks. Bye-bye.